take a very small topology. R1, R2, R3 connected. The network between R1 and R2 will be 12.1.1.0/30. This will be the network on between R1 and R2. And the first valid IP inside this network is 12.1.1.1, which will be configured on R1. The second valid IP inside this network is 12.1.1.2. It will be configured on R2. Between R2 and R3, it will be this network where this valid IP will be configured on R2's interface and this valid IP will be configured on R3's interface. Let us configure the IP addresses quickly. IP address on R1's F0 by 0 interface is 12.1.1.1. So on R1, we'll go to the global configuration mode and then we'll go inside the interface and configure IP address 12.1.1.1 slash 32 slash 30 sorry 252 in the end. No shutdown because by default the interfaces of routers are administratively down. You can see different log messages which are basically telling us that the layer 1 status came up, right? We no shut down the interface. Layer 1 status came up, layer 2 status came up. Let's go to R2. F0 by 0 has IP 12.1.1.2 and interface F0 by 1 has IP 23.1.1.1. And then finally on R3, we configure interface F0 by 0 with IP address 23.1.1.2. Okay, so we have configured this IP addresses on these interfaces. Now let us go to R1 and check its routing table. And we will see that R1 only knows about which network, 12.1.1.0/30, because this is the only network directly connected to R1. Let's go on R1 and show IP route. This is the command to view the routing table. And you can see that it only knows about 12.1.1.0/30 network. See, this representation of routing table is not good on this particular operating system. But in latest operating system, you will see representation, a good representation of routing table. Why I am saying this is not a good representation of routing table? See what it is saying. 12.0.0.0/30. Is this the network? No, the actual network is 12.1.1.0/30. So this /30 would have been here, should have been here, but it is written there. So this is bad representation on this particular operating system. But if you work on newer recent operating systems, you will see that this representation have been improved. So this is basically the class full network, that big class A network, which is 12.0.0.0/8, class A network, first octet for network, the remaining 3 are for hosts. And that big network has been subnetted, that big class full network, class A network. And how many subnets are we cared about? We care about. We only care about one subnet that we have, and that single subnet is 12.1.1.0/30. Are you getting the point? So like this, routing table is there, and it says that this network is directly connected via which exit interface? F0 by 0. So we can reach 12 network via F0 by 0 exit interface. And you can see this last thing that says C. C means that this network is connected to this router only. But if I just write this, if I just have this information inside the routing table, it is not possible for R1 to ping any IP that belongs to 23 network. Why? Because R1 does not know how to forward data to 23 network. It only knows how to forward data to 12 network. So let us debug something. Debug IP packet. Debugging is used so that you can see live packets. You can see information about the live packets which are coming on your device. So you'll be able to see those live packets on the CLI. You'll be able to see what packets are coming to your device, what packets your device is sending. All of those things you will be able to see with this debugging command. Debugging is basically a tool with the help of which you perform troubleshooting also. How you perform troubleshooting? By debugging, you can see the packets and then you can see that where the problem exists, right? Like we will do right now. Now I will try to ping 23.1.1.2. Obviously, we won't be able to ping. But because we have started debugging, we will be able to see the actual problem that is happening with the packets. Let us see. You can see this guy is saying it is unroutable. And why it is unroutable? Because the routing table does not know how to forward data to 23 network. So let us tell this router statically with the help of a static route a way so that it can forward data to 23 network. Now let us try to understand this command. We are giving a route. Route means a way. We are giving a way to few IP addresses. And those IP addresses that belong to this network. So what are the IP addresses that belong to this network? What are the IP addresses that belong to this network? 23.1.1.0, 23.1.1.1, 23.1.1.2, and 23.1.1.3. Right? So we are giving a route for those IP addresses which belong to this network. And to forward data to any IP within this network, first we have to forward data to the next hop, which is 12.1.1.2. So if from R1 you want to forward data to any IP within this network, you have to first forward data from R1 to R2, and specifically which IP? 12.1.1.2. Right? Next hop. We hop and reach R2. So this is the next hop column that we are writing. So let us write the format of static routes. For static routes, we write IP route, and then we write the network ID, and then we write the subnet mask, and then finally we write the next hop. And now when we have done this on R1, R1 can forward data to any of the IP that belongs to this network. That means now R1 will be able to forward data to 23.1.1.2 because you can see that 23.1.1.2 IP comes within this network. So if you want to send data to this IP, you have to send data to which IP? 12.1.1.2, which is R2. So let us try to do this again. Now let us see what the debug says. Debug says routed via rib. It got routed via rib. It was sent. And rib means routing information base. Routing information base is basically the routing table only that the router is maintaining. So with the help of routing table, the packet got routed. This is what R1 is saying. And you can check the routing table now. You will see that it contains information about 23 network now because we gave a static route. We statically manually told R1 about how to forward data to 23 network. You can also see this S flag, which basically tells that it has been configured statically using a static route. Right? And what is the next hop to reach this network? The next hop is 12.1.1.2. Are you getting the point? So now R1 can forward data to those IPs which come inside this network. So R1 sends data to who? R2. And when R2 gets this data, R2 will see the data wants to go to which IP? 23.1.1.2. And then R2 will again check its routing table. Are you getting the point or not? When we are pinging, the source IP is this. The destination IP is this. R1 checks its routing table. It can forward data to this IP. It sent data to R2. When this packet came to R2, R2 checked the destination IP. And then R2 checked its own routing table. Let us check R2's routing table. Show IP route. And inside this 23.1.1.0/30 network, this IP comes. So R2 came to know that I have to forward data to R3. So it forwarded. See, the exit interface is what? F0 by 1. The exit interface is what? F0 by 1. It sent it to R3. And when R3 got it, if you remember ICMP, if you remember ping, we know that ping uses which protocol? ICMP. And there are two of the messages which are used, echo request and echo reply. So echo request went, and now what will come back? Echo reply, where the tables will turn. The source will become destination, destination will become source. Now R3 will try to send this data back to 12.1.1.1 IP, and then R3 will refer to its routing table. Let us see if R3 knows how to forward data to 12.1.1.1 IP. Does it know? It does not know. The reason is because 12 network is not directly connected to R3. So obviously it will not know about 12 network. So we can configure what again? Static route over here. But let us first verify if the echo request messages from R1 they are reaching R3 or not. Let us verify this. So we'll go on R3 and we will debug this time which protocol? ICMP. On R3 we will debug ICMP protocol so that we can see all the ICMP protocols which are coming to R3 and which are being sent by R3. We'll be able to see all those ICMP messages on the command line interface. So let's go to R1 again, and again we will ping. Oh, sorry, ping. And you can see the data is being sent, and you can see on R3 that echo request messages are coming. And what are being sent back? Echo reply messages are being sent back to destination 12.1.1.1. But definitely router 3 is not able to route these packets because it does not know how to forward data to 12 network. Let us debug one more thing. Debug IP packet and then again ping, and we will see the exact problem that is occurring. Unroutable. So let us now quickly configure a static route on R3 and tell R3 a way so that it can forward data to 12 network. IP route for which network? 12. And what is the way? Right? Now nobody can stop this ping. It ping, everything went, everything is coming back. See, it is receiving messages from source 23.1.1.2 that are coming back for R1 only, 12.1.1.1. It is receiving them. So it is very important to understand the packet flow, that how actually packet flows. You should be able to visualize the flow of packet. If you are able to visualize the flow of packet, you will be able to configure static routes perfectly. That is the main point. Static routes. Like if I show IP route, view the routing table, I can see that a static route is there for this network, and there is one square brackets inside which two values are written. So let us try to understand this. So the left thing is 1 and the right thing is 0 after the slash. This thing is called the administrative distance. This thing is called the administrative distance. This tells about the trustworthiness of the source from where the router is getting network information. Right? So suppose if a thief is telling me, suppose if I know there is that guy is a bad man and he tells me about something, and some good man also told me about something about that thing, which one will I prefer? The talk that the good man told, right? So this is the same with administrative distance. So a router can get network information from many different sources. A router can get network information inside its routing table from different sources. And one of that source is what? It is static route. From static route, router gets what? Network information, because you tell it about a way to forward data to a network. Similarly, routing protocols are also routing sources. How routing protocols are routing sources? Because then routers automatically start speaking with each other and they share network information automatically. So obviously through routing protocols also a router can get network information. Through static routes also a router can get network information. And this AD value, this administrative distance value, is used to find at which sources information will be preferred, right? So maybe you trust static routes more, maybe you trust some routing protocol more. Are you getting the point? So AD is an 8-bit value. AD is the short form acronym. AD is an 8-bit value. With 8-bit, how many possibilities are there? 256 possibilities. So the range for AD can be from 0 to 255. Lower the AD, the more you trust, or the more router trusts the routing source from where it is getting network information. Higher the AD, lesser it is preferred, right? And you can see that for static routes, AD is what? For static routes, AD is 1. It is very low. That means we trust static routes a lot. Why do we trust static routes a lot? Because the administrator configures it. An administrator is working day and night on our networks so that our networks can work efficiently. So obviously we trust the administrator a lot. Are you getting the point? So that is why static routes are trusted a lot. So for them AD is 1. And this other part that you see here is the distance. It is the distance. And remember that for static routes distance is always 0. For static routes distance is always 0. Because when you configure a static route on a router, there is no way you can tell that that network is how far, right? If you are configuring a static route on a router, how can you say that network is how far? You cannot say. You don't have any value or any method of calculating that how far a network is from a router when you are configuring a static route, right? So for static routes, distance is always 0. I think this is it for static routes.